This is an interesting problem where we're given an equation with logarithms in it, and we're asked to solve for one variable, but there are other variables. So we'll be solving for the variable m in terms of the other two variables x and y. And this is also going to involve a number of the properties of logarithms. So if we take a look at, we certainly are going to want to isolate that term that has the m in it because we are trying to solve for m. So in starting my solution, the first thing I'm going to do to get this term, log m by itself, is to subtract log y from both sides. So that will give us log m is equal to 2/3 times log x minus log of y. All right, now in order to get the m by itself, we are eventually going to have to rewrite this from log form into exponential form. But in order to do that, we need to have a single logarithm on both sides of the equation. So we need to combine these logs. So the first property that I'm going to use, and let me just briefly review it here, is if you have log of something raised to a power, remember that you are able to bring the exponent down in front of the logarithm. So I'm actually going to use that property in reverse to take this 2/3 and bring it up as an exponent. So this will become log of x to the power 2/3 minus log of y. All right, so now each of these terms begins with the logarithm of a quantity. We don't have the number in front. Now we want to look at how to combine a subtraction of two logs. And again, the property we'll use there is if you have log of a fraction, that is the same as log of the numerator minus log of the denominator. So again, using that property in reverse, if you have a difference of two logs, you can write it as a single log of the quotient of those quantities. So that gives us that log of x to the 2/3 divided by y is equivalent, and we'll go ahead and put log m to log of m. All right, now once we have both sides of the equation as log of a single logarithm on both sides, if you remember the logarithm, any base, the graph essentially looks like this, and what's important about that is that it passes the horizontal line test, so it's a one-to-one function. So since log of any, in this case, the log function base 10 is 1-to-1. We know that if log of these two quantities is the same, then the quantities themselves must be equal. So by using what we know about solving equations, isolating the term involving the variable we're interested in, and using a couple of the basic properties of logs, in addition to the fact that log functions are 1-to-1, we see that in this equation m is equal to x to the 2/3 power divided by y.